Okay, now let's talk about algorithms a little bit. What is an algorithm? Now, an algorithm is a is a set, or not a set actually. It's a sequence. It's a sequence. It's a sequence of well-defined operations that provide a solution to a problem. Provide a solution to a problem. Okay? So if you have a problem that you want to solve, and let's say you're teaching somebody else to solve that problem for you, what you do is you'll give a sequence of well-defined operations that that person can perform in order to solve that problem for you, right? Now, there are a few things to notice in this definition. Firstly, an algorithm is a sequence, okay? So it means it is a set of statements that have to be executed, a set of operations that has to be executed one after the other. It's a sequence, okay? So there is a well-defined flow in which the operations are to be performed, okay? The second part is well defined. The operations that you perform in order to solve that problem must be well defined. What do I mean by well defined? So the person or whoever is solving that problem, the operations that you provide, the sequence of operations that you provide must be well defined in their dictionary, which means they must be able to perform those operations. They must be able to perform those operations, right? So for example, let's take the next slide, which is the algorithm to make a cup of tea. So you're teaching your friend to make a cup of tea, right? So here are some things that you do in order to make a cup of tea. Okay? The first thing you'll do is, let's say, boil water. Boil water. Okay. Next, you put a tea bag in a cup. Maybe put a tea bag in a cup. Uh, pour pour water, right? And add milk and sugar, right? And five is stir, stir, right? So these are the five things that you do, let's say, in order to make a cup of tea. Now you are teaching this to somebody. Okay, consider a robot. You're teaching a robot how to make a cup of tea. So what you have is a sequence of steps, right? These are the sequences. They must be done one after the other. Now, some things in the sequence may be changed, right? For example, you may first put a tea bag in a cup and then boil water. You can do this as well. Okay. But essentially, you can change it, but once you have it, it must be done in this order. Okay. You have to boil water first before you pour the water. Okay. So when you teach somebody how to make a cup of tea, you would teach them a set of operations that they can perform. Right. So that's the first point we talked about. That's which is a sequence. An algorithm is a sequence of operations. These are the individual operations, right? Boiling water is an operation. Uh, Putting tea bag in a cup is an operation. Pouring the water is an operation. Adding milk and sugar is an operation. Stirring is an operation, right? So all these are operations, and what you have is once you have a sequence of operations, then you have an algorithm. And this algorithm solves a particular problem, which is to make a cup of tea. That is the algorithm to make a cup of tea, right? Now the second part of this equation is well defined, okay? Well defined operations. So in this algorithm, what you have is you have boil water, put a tea bag in a cup, pour water, add milk, sugar, stir. When you give this set of instructions, the sequence of instructions, sequence of operations to let's say your friend, you're teaching your friend to make a cup of tea. Now, when you give this sequence of operations to a friend, you know for a fact, or at least you assume that your friend will know how to boil water, okay, or how to put a tea bag in a cup, or how to pour water, right? How to stir. So these things are in your dictionary, at least. It's your assumption that these operations are well defined. Okay. Now let's say you are teaching a robot to do that. You're teaching a robot how to boil water, how to stir. Maybe these operations are not so well defined, right? Maybe the robot doesn't know what stir means. What does this mean, stir? Okay. Then you have to break this operation down into something that the robot can understand. So you'd say, stir is take a spoon. Take a spoon. That's let's say, you know what? Let's do this. Let's break this down into smaller statements. Let's say this is 5A. Take a spoon. 5B, right? Insert spoon into cup. I don't know. I don't know. Into cup. 5C. Move the spoon in a clockwise rotating motion or something, right? Move the spoon in a clockwise motion or something. I don't know. I'm just making things up. Okay. So if now again, we are assuming that these operations are well defined in the dictionary of a robot, you know, inside the mind of a robot, these operations are well defined. Okay? The robot knows how to take a spoon, how to insert the spoon into a cup, right, into the cup, how to move the spoon in a clockwise motion, right? But maybe these operations are not required when you're teaching a friend, right? So what I mean is, when you are creating an algorithm for solving a problem which you then feed the computer, right? So when you are taking the help of a computer in order to solve a problem, you have to make sure that the operations that you give are well defined in the dictionary of the computer, right? So these operations that you give the computer must be understandable by the computer. Understandable by the computer, right? So that's one of the most important things of algorithms. And indeed, we will learn in this course uh, the concept of algorithmic thinking, the concept of algorithmic or computational thinking. Okay, algorithmic or computational thinking, which is how to think, how to think like a computer would think, okay, or how to think in terms of operations that the computer can perform, okay. Okay, now let's talk about the different parts of an algorithm. Generally speaking, an algorithm has three parts, okay. The first part is input, or taking the input. Next comes the processing, and finally the output, okay. Now, the input is not compulsory. You may have algorithms that do not take any input. Okay? For example, in the tea making algorithm example, we did not take any inputs, right? We just started straight away with solving the problem at hand, which is making the cup of tea. Okay? So, an algorithm need not have to have an input. The second part is processing, obviously, which does the bulk of the work. And finally is the output, is which is the solution to the problem that you're trying to solve, right? So if we have to change our tea making algorithm so that it now takes input, what inputs can you think of? Okay, so let's say you want to pass some input to the tea making algorithm. What inputs can you think of? Now, you may have said one of the inputs can be the type of tea, okay, type of tea. So is it black tea? Is it green tea? uh, is it herbal tea? Okay, because because if you go back to the algorithm, right? If you go to the algorithm, I said put a tea bag in a cup, pour water. I should have added one more step in here, which is steep, right? Which is essentially wait, right? Steeping is waiting. That's it, right? You steep the tea bag in the hot water. So maybe you steep for 5 minutes. You can steep for, I don't know, 3 minutes, depending on what the type of tea is, right? Maybe you steep green tea for a lesser amount. You steep herbal tea for a larger amount of time, right? So maybe you steep herbal tea for 8 minutes. So one of the algorithms can be the type of tea, and your algorithm will change ever so slightly based on that type, based on the input, on that input. Okay, so these are all inputs. The second one that you may have thought of, if not, it's completely okay. The second one may be the number of cups of tea that you want to make, right? Number of cups of tea. So essentially, look at this. The algorithm essentially remains almost the same. What changes based on the input is the amount of water that you boil, right? Number of tea bags, number of cups, the the amount of steeping time, right? So an algorithm changes so the input will change your algorithm slightly, but the basics, the sequence of steps, right, would remain the same. There would be small changes here and there.